Hello everyone. So today I'm going to solve 10 GRE questions on data analysis. And if you find this helpful, please like, share and subscribe. So for the very first question, we are given this function of x and we are asked to compare quantity A, which is f of 4, and quantity B, which is 75. So the first thing that we're going to do here is we are going to transform f of 4 to be in this form. Alright, so that simply means that we have to find the value of x for which 4 is equals to x plus 3 over 2. And simply that value of this implies that x is equals to 5. 5 plus 3 is 8 over 2 is 4, so x is 5. So we're going to put back the value of x as 5 into this function and then we'll find the value of f of 4. So let's do that. So here we're going to have, instead of f of 4, this will be f of 5 plus 3 over 2. And this is simply equals to 3x squared, that is 3 to the 2 to 5 squared minus 5 plus 5. Okay. And this is simply f8 over 2 is equals to 3 times 25. 5 minus 5 is 0 plus 0. So this implies that f of 4 is simply 75. Okay, so let's go back up. So f of 4 is 75. So clear 75 is equal to 75. So the solution to this problem will be C. Quantity A is equal to quantity B. For question 2, we are given a set 1, 2, 3, 4, 5, 6, 7, 8. Quantity A is the number of 4 number subsets of x, and quantity B is the number of 5 number subsets of x. What this simply means is 8 combination 4, and here will be 8 combination 5, because here we have 8 numbers here and we're trying to pick 4 number subsets. Alright, so let's do this. So 8 combination 4, this is simply 8 factorial over 8 minus 4 factorial times 4 factorial. And to the right hand side, this is 8 factorial over 8 minus 5 factorial, 5 factorial. This is minus here. And this is simply 8 factorial over 4 factorial, 4 factorial. And this is 8 factorial over 3 factorial, 5 factorial. So cancel out, we turn this to 8 factorial is 8 times 7 times 6 times 5 times 4 factorial. This will be all over. We will keep 4 factorial and we'll expand the other one. This will be 4 times 3 times 2 times 1. So the right hand side will do the same thing. 8 times 7 times 6 times 5 factorial, and this is all over 3 times 2 times 1 times 5 factorial. So the next thing we can, 4 factorial will cancel this. 4 times 2 is 8, so we can cancel 8. 3 can divide 6 to give us 2. We have 7 times 2 times 5, and the right hand side, the left hand side is simply 70. And for the right hand side, 5 factorial will cancel this. 3 times 2 is 6, so we can cancel 6, and we have 8 times 7 left, and that is 56. So clearly, quantity A is greater than quantity B for this particular problem. For question 3, we are given quantity A and quantity B, and before I do anything, let me just show you that if you have A over B to the power of -1 in indices, this is simply B over A to the power of 1, which is just B over A. If you're given A over B to the power of -5, this is simply B over A all to the power of 5. So just keep this in mind. So let's look at what we are given. Let me write it. We have 1 over 4 . Alright, so if you look at this, this will give us 4 over 1 to the power of 4, which is simply 4, plus 4 over 1 to the power of 2, which is simply 4 squared, plus 4 over 1 to the power of 3, which is 4 to the power of 3, all over 4. Okay, and at this point we can factor out 4 here. This is simply 4 into 1 plus 4 plus 4 squared all over 4. I just factored out 4 from this, and this. So this can cancel this. What do we have left? What we have left will be 1 plus 4 plus 4 squared, that is 16. And this is simply 21. So we've gotten that this is equals to 21, which means that quantity A and quantity B are the same. So our solution here is C. For question 4, we are given that m is equals to 10 to the power of 32 plus 2. When m is divided by 11, the remainder is r. Quantity A is r and quantity B is 30. So how do we go about this? First thing we're going to do is, this is going to be very difficult. If we try to divide this number by 11, it's going to take our time. It's not necessarily that hard. It's just going to take our time. But what we can do, instead of trying to solve the entire mass, is to change different values before it gets to 32 to see if we can get a repeated pattern. So what do I mean? Let's see what happens when we say 10 to the power of 1 plus 2 divided by 11. Okay, this will simply give us 12 divided by 11. See that the remainder here is going to be 1. To be 1 remainder 1, right? So let's try for 10 to the power of 2 plus 2 divided by 11. What would this be? This is 102 divided by 11. And the remainder here, this is going to be 9 remainder 3. Remainder here is going to be 3. Let's go to the next. 10 to the power of 3 plus 2 divided by 11. This would be 1002 divided by 11. And the remainder here, if you do this, remainder here is simply going to give us 1. And if you go ahead and do 10 to the power of 4 plus 2, this divided by 11, this is 10002 over 11. The remainder here is going to be 3. So as you can see that the pattern here is repetitive. So we have 1, 3, 1, 3. And this is when 10 is raised to the power of 1, which is odd. Here it's even exponent to the power of 2. This is odd. And this is even. So that simply means that if 10 is raised to the power of an even number, we are going to get 3. And if it's raised to the power of an odd number, it's going to be 1. So, and here our major problem is raised to the power of 32, which is even. So that means our remainder will be equals to 3. And 3 is equals to 3. So the quantity A and B, they are both equal. So our solution here is simply C. For question 5, you are given let x be a set of 2, 5, s and t, and y 2, 5 and t. So the average arithmetic mean of the numbers in the list x is equal to the average arithmetic mean of numbers in list y. Okay, so compare quantity A, s and b. So let's find the arithmetic mean of these two lists. So for x, we have 2 plus 5 plus s plus t. This is all over 4. They say this is equal to 2 plus 5 plus t over 3. Okay, so this is simply 7 plus s plus t. This over 4 is equals to 7 plus t over 3. So let's cross multiply. We're going to have that 3 into 7 plus s plus t. This is equals to 4 into 7 plus t. Next, let's open the brackets. Will be 21 plus 3s plus 3t. This is equals to 28 plus 4t. Okay, so if we decide to subtract 21 and 3t from both sides, minus 21 minus 3t, what we'll have to the left hand side will be 3s left, and this will be equals to 7 plus t. Okay, And we're not really giving conditions for s and t, so we can plug in values. So let's say let t be equals to -7. This simply means that 3x will be equals to 7 minus 7, which is 0, which simply implies that s will be equals to 0. And if s is equals to 0, that means a and b are equal, right? Let's plug in a different number. Let's say let's say that t is equals to 2, okay? So that means 3x will be equals to 7 plus 2, which is 9, and this implies that s is going to be 3. So we have s to be 3 here. As the first condition, s was 0, 0 is equals to 0. The next condition, it was 3. This is greater than this. So that simply means that we can't give a definite relation at this point, which means that the solution to this particular question is D. Okay, question 6. The arithmetic mean of 4 donations to a charity was $80. 2 of the 4 numbers were 90 and 60. So let's say the other 2 numbers are A and B, right? So let's solve this out. So this simply means that A plus B plus 90 plus 60 over 4, this is simply $80. If you multiply this out, this will tell us that A plus B plus this 2 is 150. This is simply 4 times 80, which is 320, right? If you subtract 150 from both sides, you have that A plus B. This is simply 320 minus 150, and this is 170. So the arithmetic mean of these two, which is just divided by 2, same as divide it by 2, and this will give us 85. So clearly this is 85, and this is greater than B, because this is the average of the other 2 donations, which is A and B, and this is their mean, 85. So A is greater. For question 7, they are given 2 sets, S and T, and A is a number in set S, so A could be any of these numbers, right? And B is a number in set T, so B can be any of these 5 numbers. So quantity A, the number of different possible values of the product AP, and quantity B is 20. So that means the product of multiplying this and this, different products, 1 times all these numbers, and then 4 times all these numbers. So the way to go about this is simply so this will be A and this is B, and there are 4 numbers in A and there are 5 numbers in B. So clearly we should be getting 20 products, 20 values for their products, but they have to be different. That's the case. So let's see if we can find, let's check if they are all different, or if we can find 2 products that are the same, which means this number can no longer be 20, right? So let's see. Here we can pick one here and times it by 8. So 1 times 8, that will give us 8, and we can pick 4 from here and times it by 2. 4 times 2, that's still 8. So that simply means that we can no longer get 20 different possible values, because we already have 2 products that are the same. So which means that quantity B has to be greater, because this must be less than 20, right? Because we have gotten 2 products that give us the same number, and quantity A has to be different possible values of the product. So question 8, the sum of the first 7 positive integers and 7 times the median of the first 7 positive integers. So what's the sum of the first 7 positive integers? That is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and this is simply 28. What about this? What is the median of these first 7 numbers? So the median will be 1 2 3 1 2 3. So the median is 4. Okay, so this will be 7 times the median, which is 28. So clearly this is 28 and this is 28. So this is, the both of them are equal. So the solution here is C. Question 9. Quantity A is the number of two-digit positive integers for which the unit digit is not equal to the tens digits. So let's start with number of two-digit positive integers, and they range from 10 to 99. And in total, they are 90 in number. Okay, you can count it yourself. One easy way of determining this is just if you take 10 to 19, this will give you 10 numbers. 20 to 29 will give you another 10 numbers, all the way to 90 to 99. These are 10 numbers, and there's 9 in numbers. So that's how we arrived at the total of 90. We have 10 numbers in this category, but then they said for which the unit digit is not equal to the tens digit. So such numbers include 1, 11. For 11, the unit and the tens digits are equal, so we don't need 11. 22 all the way to 99, and these are 9 in number. So that simply means the total number that satisfies quantity A is 90 minus 9, which is 81 of such numbers. So quantity A is simply 81, and this is greater than quantity B, which is 80. For question 10, in a probability experiment, G and H are independent events. The probability that G will occur is R, and the probability that H will occur is S. Hence, both R and S are greater than 0. Good. So quantity A is the probability that either G will occur or H will occur, but not both. Okay, so let's start by doing this. So probability that G will occur is R, right? And probability that H will occur is S. Okay, the probability that G will not occur is simply 1 minus R. Okay, and probability that H is not going to occur, not H, is going to be 1 minus S. Okay, so the probability that G will occur alone means G will occur and H will not occur. All right, and that is simply probability of G times probability that H will not happen, and this is simply R into 1 minus S. Okay, and then next is probability that H will occur but not G, but not both, which means probability that H will occur and probability that G will not occur. And this is simply H will occur is this, G will not occur is this, which is S into 1 minus R. So that means what we are looking for here, and when we have OR, that means addition in probability. So that simply means that what we're doing here is the probability that G will occur and H will not occur, or the probability that H will occur and G will not occur. And this is simply R minus RS plus S minus RS. And this is simply equals to R plus S minus 2RS. And mind you, R and S are positive numbers. R plus S minus 2RS. And here we have R plus X minus RX. We can subtract R plus X from both sides minus R plus X. And what we have left is negative 2RX and negative RX. We can divide both sides by RX, and what we have is divided by RX divided by RX, we have negative 2 and negative 1, and clearly negative 1 is greater than negative 2. So simply quantity B is greater than quantity A, and our solution here is B. So thank you very much for hanging on with me. I hope you found this helpful, and if you do, please subscribe, like, and share. I'm going to drop another video until this time, and as I told you, within 10 videos we should be able to get you ready to hit a very high score on your GRE. Thank you very much.